Thank you. So I'm Kat James. I'm a senior data scientist at Royal Mail. Royal Mail, not a typical retailer, probably is what you're thinking about, but my background's very much been in retail and customer. I worked at British Airways, building recommender systems that recommended where you want to go on holiday, which is a lot of fun for a model to build, to look at all the places, not go to them, unfortunately. And then I moved into the insurance industry, so I worked at Aviva, working on how we recommend different insurance products, how we use customer data to target and to enrich our customer touchpoints. So today I'm going to have a slightly unusual talk, and I'm going to talk about offline applications of recommender systems at Royal Mail. So we have two main ways we're using recommender systems, both extremely different. One really does fill somewhat the traditional space. The other one is kind of moving them completely out of where we expect them to be, seeing how that works. I don't know how many of you, I guess you all know what Royal Mail is. I don't know how many of you know kind of some of the data we deal with at Royal Mail on a daily basis. So Royal Mail is a 500-year-old company, quite astoundingly. We deliver to 29 million households every day, 6 days a week. That's part of the universal service application, which I'll talk about in a bit. But obviously you can imagine we have a huge amount of data. That's about 16 billion letters and parcels annually, about 50 million a day. So you can imagine the data. We've got scans, we've got machines, we've got all sorts of stuff. And we also collect from 115,000 post boxes, give or take, and businesses. All of this is done through our network. Our network comprises about 1,400 delivery offices, which is probably what you think of as a sorting office. We don't have anything called a sorting office technically, but there you go. That goes through 40 mail centres into 45,000 vans. Eventually ends up with one of our 100 to 150,000 posters. And all of this data is curated and used by a team of 16 data scientists. So you can imagine we're pretty busy. So that's the data, great, rich, everyone in the country, 6 days a week. These are the challenges that we have with using this data and with how we operate as a company. So I said we're 500 years old. We might not be. We might be 5 years old. So in 2013, Royal Mail was privatised. Alongside that privatisation brought a lot of change, the necessary change that we needed to deal with competing in the open market, but also a lot of want to kind of improve our efficiency and the way that we operate. So are we 500 years old or are we 5 years old? We're probably neither, but it's an interesting place to work because of that. We're bound by something called the Universal Service Obligation. So the Universal Service Obligation is part of the UN Charter of Human Rights, so it's really serious. You know, it's not an optional thing that we've signed up for. And we're obliged, as part of providing communication, the right of communication, to deliver every address in the country at the same price, 6 days a week. So we have to act like a monopoly, but we're not a monopoly. Our monopoly was broken. We have to allow people to use our network. We have what's called downstream access. So the challenges that we face in terms of how we can use data and how we can improve as a business are enormous and really quite unique. Just thought that might be interesting for you to know. So the first thing I'm going to talk about is what we call slow recommendations. So this is these are offline in that we don't actually market digitally much at all. All of you probably know, if you work in retail, that we sell mail products and advertising products to the retail industry mainly, but also to other delivery firms. We sell mail products to around 300,000 customers, and we have approximately 30 products that fall into 6 branches. So they're things like tracked, special delivery, all the kind of things you know about Royal Mail. And we were kind of targeting them with a very basic customer segmentation, but we thought, let's stick a recommender on it, see how it works. So this is the basic model that we used. So we built a user item matrix using 12 months of purchasing data. So the metric that we used for the kind of how much someone likes a product is how much they've spent on it. We use single value decomposition to factorize the matrix and find the latent feature space. I'm sure if all of you know about recommenders, I won't go into it, there's not much time, but it's quite a standard model really. And latent features were then used to score the missing items for customers. So if you hadn't purchased an item, we were able to predict your interest in that item based on the latent K matrix we discovered. But that wasn't all. I think if we've all worked in recommenders, we know that the best thing to do with a recommender is build another recommender and another recommender and another recommender, stick them all together. So we have more data on our customers than just purchasing history. Obviously, if you build a recommender on revenue, you kind of get an okay model, but not that great. So we used our single value decomposition model as the base, and then we stacked customer segmentation that we had. So the green bottom line is how successful we were when we were using the basic model. We then put customer segmentation on top, which slightly improved things. And then we additionally split our customers into whether or not they were account handles or non-account handles. I won't go into the reasons behind that, but that obviously gave us quite a great improvement in performance. So this is our traditional space recommender. It's going into A/B test. If any of you get any marketing comms from Royal Mail, watch out for it. But yeah, so that's kind of where we're using them traditionally. And then I thought I'd go into where we're using them in a more kind of to a different angle way. So this is what we call quick recommendations. So we have a network, as I mentioned. We have 1,400 delivery offices, we have 40 mail centres, and then the mail goes into the mail centres and then back out to the delivery offices to be delivered in what we call the final mile. So that's when someone walks to your house and puts a letter through your door. Obviously, this has a lot of information in it. That machine at the top there is our letter sorting machine. What that does is it takes a picture of every envelope, 45,000 an hour. It reads the barcode. All of these bins here are for different delivery offices, so it sorts the mail into those. But we have data from that machine. We can count. We can say, you know, I've just sorted 10,000 letters for Holborn DO. So we have this sort of information. This is the mail centre floor. It's incredibly hectic. So we've got data pouring in from streams there. And we wanted to know, can we use a recommender system to make data-driven decisions in real time? So we're not talking about selling things. We're talking about recommending items, which are pieces of data, or recommending actions in a real-time setting. So you're a delivery office manager, you come to your delivery office, 6 o'clock in the morning, and our recommender's chucking information at you. And it's saying, you know, we saw 10,000 letters, we saw 10,000 parcels, these sorts of things. Now, there's a problem with doing that. Sounds very good on paper. We don't have any users, and we don't have any items. So what level do we define the user at? So this is someone choosing a product, very typical user. We have posties, are they users? We have mail centre managers, we have delivery officer managers. It's a real toss-up between, do we have 150,000 users or do we have 1,400 users? That's postie, sorting post, by the way. And the other problem we have is that we have items. So, you know, we don't just sell films, we don't just sell flights to Barbados. We have all sorts of things that we might want to recommend. And how do you know, so this is a snowstorm, how do we know that a snowstorm is more important than 10,000 letters is more important than, you know, anything like that? So the first thing that we're doing is we're looking at how we redefine the recommendations. So this is special delivery. I don't know if any of you probably all posted by special delivery. For us, special delivery is extremely important. It's our highest revenue stream. So if we know that we've got a special delivery that was missed or is about to be missed, that's hugely important. That's a Royal Mail lorry that's had a crash. That happens a lot. When that happens, the post won't come to you. So you'll know that you've got a special delivery. We'll have told you from the mail centre, here's a special delivery coming your way. But where is it? We're not sure. So in this sense, not all recommendations are created equally, and they temporally vary in importance. So we're looking at how we redefine recommendations. So this is still very much work in progress. I haven't really got much more to tell you on this, other than this is a kind of some of the things we're thinking about. So how do you define a user when you don't have a traditional user? How do you define the content of the items that you wish to recommend when they're variable? So, you know, we've got a serious weather event versus parcels haven't arrived. So kind of they're the things that we're thinking about, and it's kind of interesting. I'd be interested to chat to anyone if anyone's got any questions. The other problem that we have is we have to measure non-explicit success. So in the traditional space of recommenders, I recommend an item, perhaps you click on it, perhaps you purchase it, I know that that recommendation was useful. How do you do that when I tell you there's going to be a snowstorm tomorrow and I have no way to know that that recommendation went anywhere or that it was any way helpful to you as a delivery office manager? So we're playing about with a few ways that we can measure these. Obviously, we have performance targets in the business that we can track the movement of. Anyone who's ever tracked the movement of a metric will tell you that there are so many confounding factors that that's extremely difficult. So we are doing that. But one of the main things that we're looking at is we're looking at the way that we present the recommendations. So we're currently looking into presenting them on a mobile platform. And if we present recommendations on a mobile platform, we can start to put in clever little things that let us measure. So we can give you the recommendations, or we can let you bypass the recommendations. And so we can see, do you go for the things that our model's telling you are important, or do you go for the things that you think are important? And how that kind of gives us some idea of how the recommendation engine is performing at the operational level. Yeah, so as I say, that's it. We're still very early days in this, but I thought it might be interesting for you to hear about kind of different use of a recommender and how we can try and take recommenders to drive data-driven decisions in a very, very operational setting. Thank you.